So, welcome to our next module. So, in this particular module, the main agenda of our module is so we are going to look into the planning. So, the main thing of this particular module is the planning. So, we'll be looking into the what do you mean by a planning, the definition of a planning, what is meant by a goal stack planning. As an example, we are going to look at the planning. So, later on, so we will be moving into the what do you call the learning stage. So once we have done with the planning, so we'll be moving into the learning stage. So now before let us start with our presentation. So let me start. Okay, so what is the advanced problem solving approaches? Now till this module, now we have seen the introduction of AI, then we have seen the knowledge representation. That is, first we started with searching, then what all the different type of knowledge representation. Now when you want to solve a particular problem, in order to solve some of the very complicated problem, now always it is necessary for us to combine the basic problem solving capabilities. What is our basic problem solving capabilities? Now we have to look into the problem solving capabilities as well as now we try to combine with the knowledge representation mechanism. Now what are the different ways in which the knowledges are been represented? So we have discussed that in our previous module, whether it is including in the normal knowledge representation, or we have dealt with the even the uncertainty knowledge representation. So now the main idea is that what is our problem solving strategy. So when we have got a problem, now how we are going to solve our particular problem strategy we are going to see, and then we will try to understand the knowledge representation mechanism. So now when we are going into the actual definition of a planning, now what does the planning says? So we'll just we'll go to the next slide. Now what is our planning? So now there is various definitions what we can give for a planning. So one of the simple definition what we can say is that planning is arranging a sequence of action to achieve a goal. As we all know that we have some goals to achieve. Any problem when you want to solve, so now we actually have some goals which we are going to achieve. So now to achieve this particular goals, so now we are going to plan something. So that's what when we are saying a planning, what it says, so it is an arrangement of sequence of actions. Now to solve or to achieve one particular goal, so you are defining some sequence of actions. So you want to perform these actions, and these actions are to be performed. You have to arrange these actions in a sequential manner. So what we are going to say, so you are going to arrange some sequence of actions in order to achieve a particular goal. So this is how, in a very simple term, we can define what is called as a planning, right? So now this particular planning, it is used in lot of AI applications. Like you can see here, whether it is in robotics, whether you are talking about navigation or language processing, computer vision. So lot of applications are there where the planning is very important for us. So now let us try to look into in still more detail about what actually the planning consists of, right? So now what we told that, so what do you mean by a planning in AI? So a planning in artificial intelligence is about decision making. Just now what we told, so just now we told that, so you are going to have some sequence of actions in order to plan. So you are going to have some sequence of actions. So when you are having, even we can say that the planning in AI is about decision making. So you are going to make some decisions, right? So you are going to let me take the pen. Okay, so now you are going to make some decisions. So these decision making tasks, or what you have called it as actions, now performed by some robot or some computer program to achieve a specific goal. So we can say it as as our planning itself. The execution of this particular planning, So now it depends upon the execution of this particular planning is about choosing the sequence of action. So just now what in the previous simple definition we told, you are going to select some actions are required for us to solve a particular problem, and the sequence in which these actions have to be performed is exactly what you call the planning. So you are going to execute that. So you are going to execute this particular planning. So this is what we call it as a now the choosing or selecting the sequence of action to achieve your goal. So planning refers to the process of computing several steps. We have several steps. The sequence of these steps or the actions, we are going to call it as a planning. Even in another term we can define that. So we can say the planning is an arrangement of sequence, right? So it is an arrangement of sequence of actions to achieve a particular goal. So now let us try to take one simple example which is very popularly called as the block word problem. So now this is one of the very important problem when it is discussed in AI generally when you are talking about a planning. Now what does this block word problem says that? Now it is a very simple problem. So as we have already discussed in the class, so now this particular problem what it says that now we have got square blocks of same size, right? Now blocks can be stacked one upon the other, so you can keep the block one upon the other. There is a flat surface or a table on which the blocks can be placed, and we have got a robot arm that can manipulate the block. That means it can pick up the block and only one block the robot arm can hold. So now in this type of a problem, what we call it as the block world problem. So now the state is described by set of predicates. Later we will be seeing what do you mean by a predicate. Every state now will be defined with certain predicates which represent the facts that were true in that state. In one particular state or one instant of a problem, now you are going to have some predicates now which is nothing but the state. So one we have supposed to describe for every action, whatever action is required to solve the problem. Now each of the changes it makes to the state description. That means, now say for example you are in one particular state X. Now once you are in this particular state, you have so many actions are there. So you have to, from this state X, you have to go towards your goal. So you are having a goal state. So from here if you want to go to a goal state, now there are some predicates which are being defined, and these predicate it represents the actions. So for every action, when you apply this particular action to X, to this particular state X, now X changes from X to another state Y. So we can say this is an intermediate state. It changes the state. So this is how we are going to define. So block word problem. Now in a pictorial diagram way it is more clear for us. Now what does this particular block word problem say that? Now say for example, now this is a flat surface, right? A flat surface table is there. Now we have got some blocks which is kept. Now we can call this as our initial state. So now this is the initial state for us. So this is our initial state, and let us say that now you are going to define some goal state, right? So now what might be our goal state? Now say for example, now you have got A, B and C blocks are there. Now let us say that this is our goal state. Now you want to achieve a goal state in this particular fashion. So you want A block here, so you are going to keep B block here, and you are going to keep C block here. Now this is our goal. So now this is the initial state. So from this state you are going towards the goal state. How we are going to do in block world? Now there are certain conditions are there. So one block can be stacked on the above. You have got a robot arm here. This robot arm can hold only one block at a time. So it has to lift one block and it has to arrange this block in a goal state. How is our required goal state? Now to do this, now we are going to have some predicates. As we told that in order to achieve this, now we have to define something called as a predicate. Now just listen carefully, what are the predicates we are having? So we are going to have 4 predicates, right? So now if you want to have this particular setup, that means if you want to arrange these blocks in this particular fashion, we need to have 4 predicates. Now what are that? The first predicate is, now we call it as unstack A comma B, or in general you can say unstack So we can just say now unstack, right? So unstack x comma y. In general I can say x comma y or a comma b. So unstack means what? You have to remove, you are going to remove. So now when you look into this particular predicate unstack a comma b, so what is the meaning of this particular thing, or unstack in general x comma y, what is the meaning? You are going to remove block A from block B. Now say for example, now you are having, this is our condition, or let us say this is the state, right? So now you have got like this A comma B. Now block B is on block A. Now if you want to remove this, if you want to go further to solve the problem, I have to remove B from this, right? That then I will apply this particular predicate, or this action I am going to apply. What is that action? I want to unstack A comma B, right? So you are going to remove block A from block B. That means when we are saying unstack A is the first argument, right? That means this is not correct. Now how it should be? First is your block A, then you have got block B, right? And this is our table. Now you are going to unstack A. You are going to remove this block A from block B, right? Now when you are going to do this, now these are all, we can say these are some of the precondition which should have. In order to apply unstack, arm must be empty, as we know, because if you want to lift this block A, the robot arm has to be empty, and block A must not have blocks on top of it, right? It is very obvious. Now if you want to remove this block A from block B, you should see that on top of this block A there should not be, we should not have any block. It should be clear, block A. So block A must not have blocks on top of it. So this is one of the action or the operation which you want to do, can be done by the robot. So the second operation is similarly like how we told unstack. Now we are having stack A comma B. So stack means put, unstack means removing, right? So now, so like say for example, now if you have got a block B is present on the table, right? Now you have got, let us say block, assume you have like this scenario, C is there, A is there. Now if you apply this operation, now you want to keep A on B, so then you can apply this operation or action which takes stack A comma B. Put this block A onto top of block B. So that is put block A on block B. Now to do this, arm should be empty, right? Our robot arm, what you are going to consider, now it should be empty so that you can pick this block A. Next, the arm must already be holding A, right? So now once the arm is empty, so then you can hold this A. So then you can apply another operation wherein which you can hold this block B. Now you want to keep this on top of B. That means B should be clear. There should not be any other block. So the surface of B must be clear, right? This is our second operation, unstack. So we have seen two operations. It is very, very important to understand these things. So unstack A comma B, stack A comma B. Now the third operation, what we are going to see here is the pick up A. Now pick up A means what? So pick up block A from the table. So the robot is going to pick it up. So you just apply. So when you are saying pick up, you want to pick, you know that the robot arm, the condition is given that it can hold only one block. So obviously you have only one argument, pick up A, or in general pick up X. You pick up any block. So now to pick up that particular block, now what it says, pick up block A from our table. The arm must be empty, right? And there must not be anything on top A. Suppose say for example, you have got, this is our setup. So you have got block C here. Now if you want to apply this action, pick up C, you are going to sell pick up C. Now to do this, what should be there? Arm must be empty. So your robot arm, it should be empty. Where if it is empty, then you can say pick up C. Next, what the next condition is, if you want to say pick up C, you have to see that on block of this block C here, no block should be there. It should be empty. Then only robot can pick this up, right? So this is very clear. So third operation is our pick up operation. The fourth one is put down, right? So just like when you are picking up a block, you are going to put it down. Now where you are going to put down? So to use this put action put down, so what it says, put down A means you put block A on the table. The arm must be holding this block A, so it should be holding A, then only you can put it down. So these are the 4 important actions we are going to have. So now these actions, so now the we will be having some predicates are needed, so to perform these actions. That means now if you want to apply this action, if you want to perform this action, whether unstack A comma B or stack A comma B, or third one pick up A or put down B, you need to have some predicates. Now these are all the predicates which are being defined for us. Now what are the predicates which are being defined? The first one is A on table B. That means block A is on block B. So block A is on block B. We write it as on A comma B. You are going to read it as block A is on block B. Now similarly on table A, right? On table A means block A is on the table. Clear A. So clear A means there is nothing on top of block A. Holding A. Holding means robot arm is holding this block A. It's not that A or B, in general X or Y, right? Arm empty means the arm is not holding anything. Now these are all the following predicates which is been required for us. Now let us look into a pictorial representation of our the 4 actions what we have just now defined. So what was our first action? First action was unstack X comma Y. Now say for example, now this is our situation what we are having. Now when we take this unstack X comma Y, now there are certain predicates. Now if you are going to say that unstack C comma A, right? X comma Y is there. Now you are going to say, let us say that you are going to say unstack C comma A. Now if you want to unstack this C comma A, so now what is the preconditions? Preconditions, there are some preconditions. So every actions has got some preconditions, and when you apply the rule, what is the outcome it is going to happen? So what will be after doing that operation? Now let us take the first action, unstack X comma Y. Now to unstack X comma Y, there are some preconditions. Now if you look here carefully here, if you want to unstack C comma A, now there are some preconditions. What is that? Robot arm should be empty, right? The second one is, if you want to unstack C, on top of C there should not be any block, right? That means clear C. Now you can see here, one is hand empty, robot arm should be empty. The second one is on top of this C, right? Here C, here we have written X. It is nothing but saying in general unstack X comma X comma Y. If you want to remove this X here, now what it should be there? X should be clear, or C, there should not be any block on top of C, so clear C, right? So then X should be on Y. X should be on Y, right? That means when you are going to apply this action unstack C comma A, so C block should be on top of A block, then only you can apply. Suppose say that if the problem is like this, if block C is here, B is there, you cannot apply unstack C comma A. This becomes wrong for us, because to apply unstack C comma A, C should be on A, but C is on B. So now we can see that these are all the preconditions. So now when you look here, the precondition on, we have on X comma Y, clear X, hand empty. Now if you go to our previous slide, now here we have defined that we need some predicates. Now if you observe here, these are the predicates we have on, right? See here in here we have said on X comma Y. Now we have got on A comma B. What is the meaning of this? Block A is on block B. Now if you go second, clear X, so clear A, clear X, that is there is nothing on top of block B. Like this, when you are going to look into that preconditions, now these are the preconditions which we have defined it as a predicates. Now these are the 3 preconditions to apply this particular action unstack X comma Y. Now once you apply this operation, what is the outcome you are going to have? Because we know already, we have studied that every rule has got some preconditions, that is left hand side of a rule and right hand side. So once you apply the left hand side, when it matches, you apply the rule, then you are going to get a new state. So what will be there in new state? Now we can say negation x on y. Negation x on y means, now once you apply this, you have removed this, then obviously this block is not present. So we can say negation x on y, x is not clear, right? So now once you have removed it from here, so now this particular x may not be clear, right? And arm not empty, right? Because already the robot is holding something. So arm not empty, so holding x, right? Arm not empty means before applying this unstack x comma y, arm was empty. Once you apply this rule, now arm is holding C here, like this. Arm is holding C. Now when you say arm is holding C, obviously arm is hand is not empty and it is holding x. And when it is holding x, obviously C is clear. Now this is the outcome, we can say, or once you apply this unstack, this is the resultant what you are going to have. Clear? This is about unstack. Similarly, stack x comma y. If you want to place one block on another block, what is our precondition? Your robot arm should be holding that block x, and you are going to place x on block y. So block y should be clear, right? Once you apply this, so x not holding, right? Robot is not, we won't be holding because you have stacked already, and you have kept x on top of y, so obviously y is not clear. So now what you have achieved? You have achieved x on y. Stack x comma y means you are putting x is on y. Now you have applied this rule, so x will be on y and block x is clear and robot arm will be empty. So these are the output what you are going to get. Now similarly, the third one is the pickup a, right? Pickup a or pickup x, similarly put down. So to do that, again we have some precondition. Pickup x means, prior to the precondition, x should be on the table, x block should be clear. That means there should not be any block on that x. Say for example, you are going to say pickup b here. Now if you want to look here, if you are going to say pickup b, right, what is the precondition? X should be on table, so b is on table, correct. This holds good, the condition holds good. Look into the next condition, clear of x. Is b block clear? Is there any block on top of b? There is no block, so clear. This is also, the second condition is true. The third one, hand empty. Is robot hand empty now? Yes, it is empty, so this condition also holds good. Now all these three holds good, so now you can apply this rule, or you can apply this action, pick up x. So when you apply this action, this is the what you are going to get, right hand side of your rule. Similarly, put down x, right? So put down x. Now if you are in this state, if you say put down b, right? So what is the first precondition? Robot arm should be holding b, so holding b, right? So it should be holding b. And then you are just telling put down. You can put it on the table or on block of this C block. You can put the B block also. It doesn't mind for us, until and unless what is the problem we are having when you are going to solve the problem. So just one precondition is there. That means the robot should be holding this particular block x, block B or x. Now this is the various preconditions what we are having for all these predicates. I think it is very clear for us. Now when you look into these predicates, now we can even represent this by using our propositional logic, or that is our first order propositional logic, FOPL. Now say for example, now we can write it for there exists x, x is holding, if robot arm is holding x, it implies that arm is not empty. Because if already your robot arm, if it is holding some block x, right, if it is holding some block x, we can say that it is not empty. Or say for example, for all x, if x is on table, right? For all x can be block A or block B or block C depending on our problem. For all x, if that particular block is on table, it implies that there does not exist y, right, where x is on y. So like this, so if a block is on particular table, then it is not also on another block, because if already we are telling this block is on table, if we are telling that now block A is on table, what does it means? It means that this A is not on any other block. Like this we can write the rules we can convert these rules into our knowledge representation also in a very easy manner, right? So this is how we try to work. So now it is very clear for us when we look into our block world problem. Now with respect to definition of a planning, now what we told, now these are the actions. If you want to reach a goal state, you have to perform these actions. What are the actions in this block world problem? Unstack x comma y, stack x comma y, pick up x or put down x. You have to do this action in a sequential manner. How you are going to select these actions, that is what planning is required. In order to solve this problem, you have to plan these actions in a systematic, in a sequential manner. Then we say that is how we are going to define what is called as a planning, right? So now this is about the definition or understanding of our block world problem. So now we will go into the components of a planning system. This is one of the very important question which can be asked in your examination. Explain or define the components of a planning system, right? So now what is the component of our planning system? In any general problem solving system, elementary technique to perform the functions are as follows. So we can say that our planning system, in order to plan to solve a particular problem, so now we are going to have this stages, we can say, right, or the steps we can say. What is the first step you are going to follow? First step you are going to follow is choose the best rule, right? As we told that we will be having so many rules will be defined in our knowledge system. Now out of these rules you are going to select or choose the best rule. Now how you are going to select the best rule? Based on some heuristic. So you need to apply some of the heuristic method and you can try to select a rule. That is our first step. The second step says that apply the chosen rule to get a new problem state, right? Now already told you have so many rules are there, right? Right now you are in one particular step, stage X. Out of these rule you pick any one best rule and you apply this particular rule. When you apply this rule to this state X, you move from X to some other intermediate state Y, right? So second step, what our second step says is, say here is, apply this best rule, whatever rule you have chosen from the previous step, to get a new problem. Now you got a new state, new problem is there, new sub goal you got, right? Like this you keep on applying the rule. And the third step says detect when a solution has been found. So when you have found the solution, right? Then fourth one says detect dead ends so that new directions are explored. So when you keep on solving, see, from X you went to a state Y. From here again you applied some rule and you go to another state, let us say yes. From here you applied another rule and you go to another state I. Like this you keep on moving, but your goal is there. You have to reach to your goal state, right? So sometimes you may not reach. So it says that detect when a solution has been found. Now you are going to check every time when a new sub goal comes, you are going to check whether this is a solution with your goal. If it is not the solution, apply some other rule, right? When you keep on doing it, there is a chance that you reach some dead ends. You may not get the solution, right? At that time you have to decide, okay, now in this direction I am not getting the solution, so we have reached a dead end, so that you can stop it here and go from new directions. New directions has to be explored. That is our fourth step. And fifth step is repairing an almost correct solution, right? So you have to repair whenever you are going to get a correction, you can refine that particular thing. So these are the important components of our planning system. Now you are supposed to explain in brief each step or each stages what is being present here. Now let us look into the one by one. So the first step says that choose the rule. So you are going to select the rules, right? Now when you are going to select the rules, now what is the generally you are going to, or strategy you are going to use in order to select rule? Always you are going to see that you are going to find the difference between desired goal and the current state, right? So you are right now in some particular current state and there is some goal. Now you find what is the difference between this. Always see that when you keep on applying your rule, you are moving in such a way that the distance between your current state and your goal state reduces. So isolate a set of difference between desired goal and the current state, right? Identify those rules that are relevant to reducing this difference. Always when you are choosing the rule, select such rule which always reduces these differences. If more than one rule you found that it is matching, right? If you found that there are more than one rule where all its left side of the rules are matching, then you try to resolve that particular conflict by applying some heuristic or some other method, right? Now you can see the same thing is given. The first step is what? Choose the best rule based on some heuristic functions. How do you do that? By finding the difference between current state and the goal state. Always select such a rule, or the best rule will be that one which reduces the difference between your current state and the goal state. So one simple example is that which can be used in our means end analysis. This is one of the searching method. Now what it says that, now wishing to travel by car to your friend's home, right? Now you want to go to your friend's house or visit your friend's house by a car. Now this is your goal. Now to do that goal, now there is some substate or some rules you are going to apply. So what is that first one? First rule says that first rule you are going to say fill the car with fuel, right? You have one rule. Second one, if you don't have a car, acquire one. So like this there are some rules will be there for us. Now you have to select any one rule, so that right now you are in your home. Now which rule you are going to specify? So it is telling, say suppose if you assume that you don't have a car, are you going to apply the first rule? The first rule is applied if you already have a car. Before you are traveling to your friend's home, you are going to fill the fuel in that. But if you don't have a car itself, you cannot apply this rule, because by applying this rule you are not moving towards your goal. You have to reduce, you have to see that the difference between the current state and the goal state is been reduced. So depending upon the current state, you have see which rule is best for us and you apply that particular rule, right? That is the first thing. The second one is apply this rule to create a new state. This is the second rule. So the second rule says that apply this rule. Once you apply, you select a particular rule and you are going to apply that rule. Once you are going to apply that rule, you come to a new state. Already we have discussed that. So each rule simply specifies the problem state that would result from your applications, right? So you are in one particular state, apply the rule, so which takes you to some other state. Like this you keep on moving from one state to another state until you reach the goal state, right? This is what the second step says. So when you are applying this rule, when you are applying this rule to create a new state, now there are certain problems. One problem which you are going to find is called as a Green's approach, right? So depending upon our problem, right? So now let us say that, so here we have two methods. Now understand carefully that when the question is asked in the examination about explain the components, you need not explain this particular what we are going to discuss now called as the Green's approach, as well as the stripes. These are the two mechanisms, two methods in which you can apply the rules to create a new state, right? So you have to just explain these steps, right? So now we will see what is that actual one of the important very important method which is called as Green's approach. So what it says, now it says basically a given state was described by set of predicates, right? So like if you take our block world problem, we have some set of predicates representing the facts that were true in that particular state. At one particular point of time in that particular state it is true, and each state was represented explicitly as a part of the predicate. Now if take a simple example of this block word problem, in Green's approach how we are going to do is that, now say for example you have block B and block A. Block A, see here, it is on, so we are going to read it as block A on block B comma S0. Now what is this S0? It represent right now, this is one state, so it shows the state, that is called S0 of a simple block word problem could be represented. This is one particular state. Now what is this state? You are going to call this state as S0, right? What is the condition, what is the actual thing what is present at this particular current state S0? We have block A is on block B and on table B. Now you can see this block B is on the table, so we say and B is on table. What is the state right now? S0. And block A, on top of block A you don't have any block, so clear, so block A is clear and corresponding state is S0. Now this entire state, now we are going to call, we are at this particular state S0. It's clear now. Now from here you select one rule. When you apply to this particular state, you go to some other state called S1. You are going to another state S1. So from this particular state you are going to another state S1. Now say for example, now you want to apply unstack A comma B. You want to apply a predicate unstack. Unstack means, you see, this is what you want to unstack. Unstack means you are going to remove this A from B, right? A from B, unstack. Stack means keep. Unstack A comma B means what? So you are going to apply this predicate unstack A comma B. Now when you look into this particular unstack A comma B, already we have seen, that's what I told. Now these things are very, very important for us. You have to write it and remember, when you are using unstack X comma Y, some preconditions after this, what you are going to have, all these things. You have to remember the predicates, you have to remember the actions, so that it becomes easy for us to look into the problem. So now if you want to unstack A comma B, the operation we are going to express this as follows. So X should clear X comma S, right? Now S is one particular state, so unstacked A comma B means this A should be clear, right? And that means on block of A there should not be any block, that it should be clear, and X should be on Y, right? X should be on Y. If you want to apply unstack X comma Y, X should be clear, X should be on Y, then implies that holding X comma, right? So now when you look here, you are going to unstack X comma Y, so robot should be holding that X, so holding X comma, now do unstack X comma Y. So now here what you are going to do is, you are going to call internally another function which is telling that you try to unstack. So to do unstack, there are some preconditions. Now to meet that precondition, again you have to apply internally another function. This is where we try to do. So this do, it specifies that a new state results from a given action. So once you are going to apply this, already assume that you are in this state S0. Now when you are going to apply this unstack A comma B, you are moving to some other state S. That is what it indicates in a very simple, if you want to understand. So now the result of applying this to a state S0, in order to give a new state S1, by applying this unstack, predicate unstack A comma B, robot arm should be holding A comma S1. You are in already a new state S1, and B should be clear, right? Because you have applied that. So since the robot arm is holding A, obviously B is been clear. So now one problem with this approach is that we say that B should be clear, but still B is on the table. So now we see that now this is the basic problem when we are going to represent with too many states S0 and S1. This becomes very much problematic for us. That is our Green's approach. What it generally says that given a state, we try to describe some set of predicates. That's the 4 predicates what you have seen: unstack, stack, pick up and put it down. All these things are to be represented in different with respect to a state, and when you are implementing that with respect to a state, now the things becomes more complicated for us. So to overcome this, so how we are going to do this, all these things are there. You need not look into all in this that much detail. So to overcome this, now we have another mechanism which is called as the stripe mechanism. That means why we are discussing this Green's approach and the stripe mechanism is, we are in which one? We are still in our second step of our planning. That is our second step. What is our second step? Applying the rule. Generally we just told that this step, what it says, you have so many rules, select one best rule, apply that best rule to one particular state, you are going to get another state. You create a new state. You apply a rule in such a way that you try to reduce the distances. Now how you are going to do? We have 2 methods. One is called as the Green's approach, where for each and every state, that is the predicates you are going to apply, it is been represented with each and every state representation, which becomes too complicated for us. To overcome that, another very simple and most popular method which was being used, it is called as the stripes mechanism. Now what is this particular stripes? So the full form of the stripes means what? Standard Research Institute Problem Solver. Now this was the which is called as the stripe, which basically used the rules, and it was developed by Fakes in 1971. So this was been one of the very important mechanism which has been used, so which we call it as a stripe mechanism, which was used in earlier in the robot problem solving system. Now what is very important of this particular mechanism and how it overcomes the complexity involved in our Green's approach? Now this mechanism is very simple. Now in this approach we are going to say that now this particular approach, it defines 3 lists. Now we are going to define 3 lists here. Again, this is a very important question in your examination. So as a short notes, they will asking you, what do you mean by a stripes mechanism, or explain the different type of list present in the stripes mechanism. Now clearly note that you need not write this in the answer or the question of explain the components of a planning system. If the question is explain the components of a planning system, you need not write Green's approach, you need not write stripes mechanism. This is separate question, you need not involve there. Just you have to explain the 4 steps or 4 components. I think it is very clear now. Okay, so now here we are going to maintain explicitly 3 lists we are going to maintain. Now what are these 3 lists? The first one is called as the precondition list. So we will be maintaining one list which is called as the precondition list. So precondition list. Now what it contains? It contains the predicates which have to be true before you are going to apply the operation. See, before you select a rule and you want to apply that rule, before you apply that rule, what are the predicates which conditions are to be true? That is why we call precondition. If all the preconditions are true, we keep all those preconditions in one list which is called as precondition list. Clear? The second list contains those predicates which will be true after the operation. Once you apply the rule or apply the operation, what the condition you are going to get. So those things are kept in another list which is called as an add list. We are going to keep that in an add list. See, already we have previously we have seen, we know that every preconditions is having the left hand side and right hand side. So here we have seen as an example. Let us go back here. Now see, here we have seen here we have written, if you want to apply this predicate unstack x comma y, there are some precondition, like say on x comma y, clear x and empty. Now we keep all these things in one particular list, which is called as a precondition list. Once you apply this operator, you are going to get some changes, that we keep it in another list, call it as an add list. That is what this stripe is telling. I think now it is very clear. Now what it is going to tell, you have a first list, precondition list, second one add list, contains those predicates which will be true after the operation. Once you apply the operation, those things we are going to keep it here. And the third one is called as a delete list. It's denoted as D. So this delete list contains those predicates which are no longer true after the operation. Once you have applied the operation, which predicates becomes false, which are not true, we just delete it, right? We put that in another separate list called as a delete list. And predicates not included on either of these lists are assumed to be unaffected. Now there might be some predicates which is neither true in precondition, or after they applying the condition it may not be true, or it's no longer been used. In those type of predicates, what we do, we just ignore it. We are not going to consider all those things, right? So now this is what this stripe mechanism says. Now we will slightly change the same thing. So previously what we have seen, so we have seen these four rules, right? That is our predicates. Now we'll see how these things are represented with respect to stripe mechanism. So you take your first predicate, stack x comma y. So we know that whenever you are using stripe, you are to maintain three lists, right? What are that list? You have precondition list, we have a delete list, and we are going to have an add list. So these three lists, now these three are represented as P, D and A, right? When you are using stack x comma y, what all the things will there in our precondition list? So now if you want to stack x comma y, there are some precondition to be satisfied, right? Now say for example, you have got like this, you have got block A and block B, one on the above. Now you want to apply stack A comma B. That means you want to put this stack A comma B. Sorry, this we can look it for unstack. Now let us say that you have A on table, you have got B on table. Now you want to stack A comma B. That means you want to keep this on this block B. To do that, there are some preconditions. What is that? Clear Y. That means clear Y means Y is what? B. That means on block B it should be clear. They should not. Then only you can stack A on top of B. When you can put stack A on top of B, if B is clear, right? That is one of the preconditions. So we are saying clear Y and holding X. Holding X. X is what here? A, right? So you are going to apply this. We'll write this as stack A comma B, right? X comma Y in general, stack A comma B. If you want to put this block A on B, there are some precondition, which is that we are keeping it in one list, which is called as precondition list. It is denoted with P. What is that? Clear B. B should be clear, holding X or holding A. So that means to put this on A on block B, your robot arm should hold this A. It has to pick up, right? Now you see, again when you look on this particular holding, now again it has got some other action has to be performed, right? So now this is our precondition. Now after applying this rule, what will be the true for us? So suppose say that you applied stack A comma B. When you applied stack A comma B, this is the result what you are going to get. A will be on B. So now what is the true? Now we are going to say that arm empty. See, once you keep the A on top of B, now what will be there in your robot arm? It is empty, right? Robot is empty. A means what? Precondition. What is this list A says? A is add list. See here, add list. Add list contains those predicates which will be true after the operation. once you have performed the operation, so once you have performed this particular operation here, once you have performed this operation here, now what will be true? You can see here arm is empty, robot arm is empty, X on Y, that means block A is on B, right? A is on B. Previously this was there, now it is there. A becomes A is on block B. So now this we keep it, name it as another list called as A. Now there is another third list called as delete list, which is not true. That is a predicate which is not true, right? Now clear Y. So now clear Y. Now you can see that this particular B is not clear. Before applying this rule it was there, B was clear. Since B was clear, then only you applied it. After applying, see what has happened is clear Y. So now it is not true. And holding X, it's also not true. So these things we put that in a delete list because you have applied, right? Delete list contains those predicates which are no longer true after the operation, right? So before your operation this was the precondition, and after your operations the same thing comes in your delete list because you have applied. Once you have applied, it is completed. Clear? So like this, now we rewrite the same predicate like stack. We have written unstack. For unstack X comma Y, now your precondition list will be what? X is on Y, X should be clear, and robot arm should be empty. Then only you can unstack X comma Y. Right? And in our add list, what will be there? After you apply unstack, so robot arm will be holding X and Y will be clear, and right, and which is be false, we put that in delete list. So previously X was on Y. Now when you say unstack, robot is holding X. So obviously in delete list X is not on Y and arm empty, that becomes false. So all those false we put that in delete list. Similarly the third predicate pick up, we have got P and D. We try to maintain. For pickup, preconditions is what? Block C should be clear, that or X should be clear, X should be on table, robot arm should be empty, then only you can pick up that block X. Next, put it down. What is the precondition? If you want to put down a block, you should be, robot arm should be holding X, right? So like this we are going to define what is called as a, in stripe mechanism we rewrite, we construct such type of predicates and we try to apply. So this is about our what do you say, this stripe mechanism. So there are so many examples. Now if you look at the way in which this stripe planning is being done, right? Now say this is a very simple example. So what we are doing is that this is the goal state what you want to achieve. You have to keep block B on C and block A on B. This is our goal state. Now say this is our initial state we are having. Now from this initial state we want to apply that. Now if you look into your initial state, how you are going to write, you can see here A is on table, the first one, right? On A comma table, A is on table. On B comma table, B is on table. On C comma table, C is on table. And clear A, there is no block on A. So A is clear, clear B. Block B is also clear, clear C. C is also clear. This is our initial state. Now we can consider this initial state as our S0. Now you want to get this goal state. Now if you observe here, you have to keep block B on C, right? Now where is our block B? It is here. Now you have to keep this block. Now what you have to do is that you are going to move block B comma table comma C. So from table, on table what B is there, you are going to move it on this particular C. Now when you keep this block B on C, now how do we write? You can see here, now A is on table, B on C. You can see the block B is on block C. This is another state S1, right? So B is on C, C is on table still, A is clear, B is clear, clear table, right? This you may write it or you may not write it. Clear table means the block B where in this particular place it is clear, that it indicates. Now the next step, we are going to another move. Now what you are going to do, we keep this A and keep it on top of B, right? Now if you are going to keep this on this, which is the predicate you want to use? We are not writing all these planning steps, so that thing we'll be discussing in later. So now you are going to stack, right? Your stack A comma B, you have to keep A on B. To stack A on B, again you have to check the preconditions. So those things we'll discuss later. Just it shows, this particular diagram shows that how each state from S1, from each one state, how you are moving further after applying some rules, so that you are going to reach your goal state. When you look your goal state, this is how we can write. How do you write this goal state? A is on B, right? Block A is on block B, B is on block C. This is how you are going to represent it as a goal state, right? Now this is our second step, what is called as a select a rule, applying a rule. First step is select a particular rule. The second step is apply the rule, choose a rule, best rule which you are selected, so that you move towards your goal state by reducing the differences. To do that, to apply the second step, now we have two approaches. One is Green's approach, the other one is stripe mechanism, right? If the question is asked, explain the components of a planning system, as I clearly told that you need not explain Green's approach and the stripes mechanism. That is a separate thing. But we have discussed that those are the two ways in which we can do. Now we will look into the third important step, that is called as a detecting a solution. So when you want to stop your problem, when you come to know that when a solution has been obtained, so a planning system should find solution to a problem when it has found a sequence of operators that transform the initial state to a goal state. So you need to have some sequence, you have to find some sequence of operators now which takes you from initial state to the goal state, so that you can say that okay, now you have obtained the solution, so that we can stop your problem. So you can stop your algorithm. You have to detect the solution when you have got a particular solution. That means every time, so you are going to compare the current state with the goal state, so that you can detect when you have got a solution. And predicate logic is a representation technique that serves as the basic for many of the planning systems. This is one already we have seen. So because these rules can easily be written in a predicate logic fashion. So the third step is detecting a solution. The fourth one is detecting the dead end. So when we have reached a dead end, that is also very important, because if you don't detect a dead end, then you are not going to get the goal itself. So our planning system, now it searches for operators which must be able to detect our goal state, right? You have to keep on detecting a goal state. If you are not getting a goal state, then it means that you are at the dead end. You have to see that also, that are you really going towards your goal state? Are you reducing the distance between your current state and your goal state? Otherwise you are ending up to a dead end. So if your searching process, suppose if you are using your forward reasoning, that is from initial state. So we have two types of reasoning which we have already discussed in the class: forward reasoning and the backward reasoning. If you are using forward reasoning, that is if you are moving from initial state in towards your goal state, so then easily you can try to check each intermediate state that whether you have reached the goal state or not. If you are not going towards your goal state, then it indicates that you are in a dead end and you have to go with the next step. Suppose if you are using a backward reasoning, that means already you are starting with a goal state and you try to from initial backward reasoning from initial state, Now it can terminate any path. So at that time what happens, the path you are going to search, it can be terminated, that leads to a state from which the goal state cannot be reached. So obviously, so we have seen that example in our backward reasoning when we have discussed the backward reasoning. If from a goal state we are going towards the initial state, if you are not able to get that initial state, then it says that you have reached the dead end. So the fourth component of a planning system is you have to detect the dead end. So in a very simple terms, if you want to see that, if you want to understand this, so each time when you move from one state to another state or from intermediate state, keep on checking that are you reaching towards the goal state. If you are not reaching after a certain period of time, try to identify that it is a dead end and you have to start exploring in some other directions, right? That is our fourth important step. And the fifth and the last component of our planning system is repairing an almost correct solution. That means when the sequence of operations corresponds to the proposed solution is executed, and to compare this situation to the desired goal. So what happens here, what does it means that repairing an almost correct solution? Many of the times we might be nearer to our goal state, and we see that the solution can be slightly refined. So that is repairing, or we can say that we can try to keep on refining our steps so that the planning should be done in such a way that you move towards your goal state from a current state in a more faster manner or a better manner. So you are going to repair and the almost correct solution. Once you get a correct solution, try to see that can you refine that particular solution. So these are the 5 important the components what we have discuss. So this is about the planning. In the today's agenda we have seen the planning, the component of a planning system. So in our next class we will be trying to understand what is called as the goal stack planning. Already we have defined the block world problem, right? We have defined what is called as a block world problem. To solve that particular block world problem, we are going to consider one type of a planning mechanism which is called as a goal stack planning. So what do you mean by a goal stack planning? With one simple example, now we will try to discuss that in our next class. So I hope that the things are more clear for you now. So simultaneously try to understand and try to read the textbook and the notes so that the things will become very clear. Thank you for watching this video. Have a nice day. Bye bye.